In the previous video, we learned how to create parametric equations from information we were given about a situation. In this video, we're going to learn how to take parametric equations and turn them into basically the standard form of the equation that you are more familiar with. Now that equation might be linear, might be quadratic, it might be exponential or logarithmic, it could be any number of things. We're going to start with the one that we already know. In fact, if you'll recall, the equation of the line was negative 1/2, y equals negative 1/2 x plus 1/2. That was the equation of the line that we came up with for the 2 points we were given. We then turned around and used the same information to find these parametric equations. So these two things are equivalent. In this video, at least at this point in this video, I'm going to show you how to take this form and turn it into this form. So let's get started. I'm going to start by rewriting these as just x equals rather than x of t. We write x of t and y of t because these are, in their own right, functions. It's just that this is a function of t. It's a function of time, and so is this one. T is my variable here. So this notation helps me recognize that t is the variable in the function x, and the same is true for y. By rewriting it, all I'm doing is kind of eliminating some of the noise, right? What I'm going to do now is solve one of these for t. And I think the easiest one to solve for t might be this one here, because if I add t to both sides, it's going to make this t positive, and then it won't have a coefficient other than 1. When I do that, I'm also going to want to subtract y from both sides. So I'll do some scratch work over here. I'll rewrite the problem. I'll add t to both sides, and I have t plus y equals 3, and then I'll subtract y from both sides. So now I have t equals 3 minus y, or if you wanted to, you could write that as negative y plus 3. Now, the reason I've done that is that I've noticed that both of these have a t in them. So if I know what t is worth, if you will, I can plug it into this equation. So now I'm going to take this equation and rewrite it down here. X equals 2 times t, well, t is 3 minus y, and then minus 5. Now let's tidy that up. X equals 6 minus 2y minus 5. I can combine like terms. Here I have x equals 1 minus 2y. I need to solve this for y if I want it in the sort of standard form. So I'm going to add 2y to both sides, both to make it positive and to move it to the sort of more conventional side of the equation. 2y plus x equals 1. Subtract x from both sides. 2y equals 1 minus x. Now I'll go over here, and then I'm going to divide. I'll rewrite this. Divide both sides by 2. So I have y equals 1 minus x all over 2, or 1 over 2 minus x over 2. Now it doesn't really look like it at the moment, but this is exactly the same equation as we have up here. First of all, we're used to having the x term first, so I'm going to rearrange this as y equals negative x over 2 plus 1/2. And then I'm going to split out the x from the over 2 part, right? I can think of this as 1 over x, 1 times x over 2. So I can write this as negative 1/2 x plus 2. You can actually stop at this point here. I continued because I wanted you to see that is not a 2. My apologies. Let me fix that real quick. So plus 1/2. And I divided everything by 2, right? So that's plus 1/2. Now this is exactly the same form even as this, but this extra work that I did here was just to show you I got the exact same equation here that I knew that these two equations were equivalent to, right? I know these two things are equivalent. This pair of parametric equations and this static linear equation are equivalent. So I continued this process to give you that form, but in fact, you can stop here because you have created a single static linear equation that is equivalent to the parametric equations. So that's how you eliminate the parameter. And it's really, really simple, and it's very, very mechanical with linear equations. These are both linear equations, so this was a very easy process. Notice that when I did this, I ended up solving initially for x, and then I had to turn around and solve for y. So I want to do this question just very quickly one more time and show you what happens if I solve for t in the x equation first. I've left some key elements on the screen. This was the first thing I did, was just rewrite it as x instead of x of t and y instead of y of t. My goal is still on the screen, and the form that I originally came up with and the work that I did after, that's still on the screen as well. This time what I'm going to do is I'm going to take this equation and solve for t. So I have x equals 2t minus 5. Adding 5 to both sides gives me x plus 5 equals 2t, and then dividing both sides by 2 gives me t equals either x over 2 plus 5 over 2, or just x plus 5 over 2. I think I'll leave it as it is for now. X plus 5 all over 2. Now that I have an expression for t, I'm going to replace the other t with that expression. So that lets me rewrite this as y equals negative t, but t is x plus 5 all over 2 plus 3. And now I need to simplify that. I get negative, let's rewrite this as x over 2 plus 5 over 2. I guess I should have done that. Hindsight's 20/20. And that gives me negative x over 2 minus 5 over 2, just distributing my distributing my negative. And I'm going to add 3 here, but I'm going to go ahead and take the time to give it a common denominator. That should be a 2, 6 over 2. And the reason for that is these are like terms, right? They're constant, so I can add these two together. So when I do that now, I get negative x over 2 minus 1 over 2. Actually, it's plus 1 over 2. If I combine 5 halves and 6 halves, negative 5 halves plus 6 halves, I get 1 half. And that is y equals. So now I have this equation, which is equivalent to this equation, which is equivalent to this equation. And all three of those are static linear equations equivalent to this pair of parametric equations. So in this case, it turned out to be easier to solve for t in the x equation and then plug it into the y equation, just because this one's already set up for y equals, and we're going to stick some x's into that position. The thing is, sometimes it's easy to do it that way, and sometimes it's actually easier to do it the way we did it the first time because, well, let me just show you. These are not always going to be linear equations. What if one of them was, say, a quadratic? Now, sometimes a pair of equations will be given to you like this, where the first equation is a quadratic and the second one is still just a linear. But in other cases, you might get the linear equation up here and the quadratic one for the y. But because this is a quadratic, it's going to be easier to solve this equation for t than this one. That doesn't mean it can't be done. In fact, let me just very quickly show you that if x equals t squared plus 1, then x minus 1 equals t squared. And I take the square root of both sides, and I get t equals plus or minus the square root of x minus 1. So it can be done, but I have this messy plus or minus in it. What am I going to do with that? Do I substitute t equals into here and deal with that plus or minus? I'd rather not. So I'm going to solve this one for t and plug that value in. I'll just erase this. So I have y equals 2 plus t, and so y minus 2 equals t, and now I have what t is equal to, so I can put it in here. That means that x, maybe I'll do it over here, x is going to be equal to t squared plus 1, but I now know that t can be written as y minus 2. Well, that means that x is equal to, this is just algebra, y squared minus 4y plus 4 plus 1. Combine like terms, x equals y squared minus 4y plus 5. Now I need to solve for y. And this could be a little tricky, but there is a way to do it. So what I'm going to do is take this x, subtract it so that it's on the same side, and I'll have 0 equals y squared minus 4y plus 5 minus x. And then I'm just going to change the order here. Y squared minus 4y plus 5 minus x equals 0. And I'm going to put the 5 minus x in parentheses. And that's just for my own benefit. This is going to help me remember something about this equation as I do the next few steps. I hope you recognize that although it's y squared, this is a quadratic equation. It's a y squared equation that has an x in it, but it's still a quadratic equation. It's a quadratic equation whose main variable is x. So I can solve this using the quadratic formula. Since it's equal to 0, I can rewrite this, or I can write using the quadratic formula, y is equal to negative b, which in this case is negative 4, plus or minus the square root of b squared, so negative 4 squared, minus 4 times a times c, and c is the constant here. Yes, it has an x in it, but that's okay. This whole thing is my constant, so 5 minus x. And that's all over 2 times a, and a is 1, so it's just over 2. Let's take this up here. That means that y is equal to positive 4 plus or minus the square root of 16 minus 4 times 5 minus x all over 2. Now, I would argue here that at this point I have eliminated the parameter. I've actually eliminated it here. Technically, I've eliminated it here, but it's not completely solved for y yet. So on one hand, you might say at this point I'm done because I have y equals, there are no y's left on the right-hand side. I do have some x's on the left-hand side, so this is now a function, y is a function of x. But it's only polite to tidy this up, right? I know what negative 4 squared is. I know how to multiply this. So the very, very least I would expect to see from you in this kind of work is this. But I can actually take it even farther. This is going to give me y equals 4 plus or minus the square root of 16 minus 20 plus 4x. Because I can distribute this 4 here all over 2. And that is 4 plus or minus the square root of 16 minus 20 is negative 4. Let's write that as 4x minus 4 instead of negative 4 plus 4x. Now I can factor a 4 out, so I'm going to get y equals 4 plus or minus the square root of 4 times x minus 1 all over 2, and I know what the square root of 4 is. So I can write this as 4 plus or minus 2 times the square root of x minus 1 all over 2. And then I can reduce the fraction. 4 over 2 is 2, and 2 over 2 is 1. So this is the final answer. This is the most polite answer. It's the most simplified. And I'm going to copy it over here to the left where I have the parametric equations. 2 plus or minus the square root of x minus 1. Now all I was asked to do here was to eliminate the parameter. But one way to do that is to graph this, and you can use Desmos for this, but you have to be kind of tricky about it. Because of the plus and minus in here, this is a square root function, and without the plus or minus, you'd only have half of the function. This is actually the inverse of y equals x squared, so we're going to need to graph two functions here to get this whole thing to graph. So on Desmos, you might want to type in y equals 2 plus the square root of x minus 1, and then underneath it, y equals 2 minus the square root of 1, square root of x minus 1. And then what I usually do is I go back and I change the second one so that the color of the graph for the second one is the same as the color of the graph for the first one. That's just kind of a personal choice thing. When you graph this one, you have to use points, the idea of plotting a point. So you have to graph t squared plus 1 comma 2 plus t. As you type this in, Desmos is going to tell you there's an error. It'll give you that triangle with the exclamation point in it. But persist, because if you get all the way through, if you type all of this in, when you close the parentheses, that error will clear. And Desmos should then produce a graph. The problem is it's only going to produce a very small part of the graph. And that's because it's going to recognize that because you've put it in this form, you're graphing parametric equations. So you're going to need to tell Desmos how far in each direction to extend the values of the parameter. Underneath where you typed this in, you'll notice there's another place to put stuff, and I think it starts out looking like this. I think Desmos tends to default to 0 to 1, and so you're only going to get a very small part of the graph. But for this example specifically, if you change these values to -5 and +5, you'll see enough of the graph to convince you that this equation is equivalent to this pair of parametric equations. We weren't asked to graph these. We were only asked to eliminate the parameter, but this is a nice way to check your work, to check your answer. If the graph for this pair of parametric equations, that's this thing right here, if the graph that you get from this does not match the graph that you get from this, then something has gone wrong. I just did this myself in Desmos to check a couple of things. One of those was that I wanted to make sure I could graph a standard linear equation, y in terms of x, and the graph of a pair of parametric equations in this form in the same screen, and you can. I actually have 3 graphs on the screen. I have one for my 2 plus square root, one for my 2 minus square root, and I've changed the colors there so they're the same. And then I have a different graph with a different color for this pair of parametric equations. That's also when I played around with the parameter to make sure that I had values here that would give me enough of the graph to convince me that it was the same as this graph here. So it's worth noting, I think it's kind of interesting, that t can be a negative number. T doesn't have to start at 0. It can be -5, for example. There are a couple of different reasons why that might happen in practice. One is that you could start looking at your data 5 seconds before whatever somebody else decided t equals 0 was. And the other is that t is not always, the parameter is not always time. Sometimes it is, usually it is, but not always. So you can have negative values here. You could go from -10 to -5, or you could go from -5 to +5, or you could go from 0 to 12. It's up to you, but using different values for the parameter will change which part of the graph you get. And that's kind of part of what parametric equations are all about. Now, I couldn't find an example in the exercises that let me do what I wanted to do with this pair of parametric equations. I wanted the x equation to have a squared in it and the y equation to be linear. So this is just example 4 from your textbook. And I think that gives us enough in the video component of this subsection. The textbook also goes on to show you how to eliminate the parameter in exponential equations and in trigonometric equations. And we'll do some of those in class. I think I'd rather you focused on just sort of the basic idea at this point, besides which the video is also already longer than I wanted it to be. So we're going to stop here. And the next thing we're going to be looking at is finding Cartesian equations. Those are rectangular coordinates or rectangular equations from curves defined parametrically.